Hey everybody, welcome back. Today we're going to be moving forward a little bit with our fantasy point projection algorithms. We're going to be building on what we had done previously by bringing in our player clusters and creating a model for each cluster rather than having one model for the entirety of the NBA. We're going to be using the same stats we used before, so we're not going to take any steps forward as far as bringing in better data. One thing we are going to try though is instead of calculating the fantasy points for the game, we're going to try calculating the delta from their season average. Just kind of get an idea, are they doing better or are they doing worse than what their average game would be? Because at the end of the day, if you can identify players that are going to have a better than average game and players that are going to have a worse than average game, you can pretty much cut the field in half and just look at players that are going to outperform their normal average. So let's go ahead and get going. Our import statement is going to be very similar as before. As a matter of fact, you can probably just copy your supervised learning from before into a new Jupyter notebook. You don't have to start completely over, but you can go ahead and import those. And then we're going to go ahead and pull in our data set. I can't do it while it's open. That's fine. Pull in our data set. And then if you take a look, I know before we had Aaron Gordon, all the Aaron Gordons, but this is the same data set just sorted by game date. So instead of by player name, by game date. So if you've been following along, you should have this. I believe it's up on the blog to download if you haven't been, or if you have your own data set, use that, no problem whatsoever. So first things first, before we start getting into the clusters, we're going to do a real quick average difference, get that delta calculation in. And that's going to be a simple, we define our pandas data set name that we're using, data set. We give the column name that we're creating, and that equals data set fantasy points for that game minus data set season av. And that should give us our difference from the season average on what they scored that night. So 19.3 points, season average is 11. We were plus 8.26 on the night. Now we're going to bring in the player clusters that we actually created in the video on this channel a little while ago. So if you have that handy, go ahead and pull that in as a data frame. And we're going to be swapping these clusters into our dataset data frame so that we can kind of group by that as we go through and make models. So you may have different cluster numbers than me if you use different variables, or if you add a different number of clusters. So that the cluster number you see here does not necessarily matter. If you have the exact same data set as me or follow along step by step, you probably do have the same, but it's not important that you do as long as you have clusters to go from. So we're going to go ahead and close that out so we can open it up here. And we're going to take a look at that data frame just to make sure. That's what we just saw in Excel. It came through all right. So the way we're going to get our clusters in, and you may think of another way to do it, and that's great. The method I'm going to use is going to be a method that I've utilized for a lot of different variables, because it's very easy to, especially when you're scraping data, right? You scrape all these tables, and maybe you only want one or two data values out of the table. But you don't want to spend your time, defining that in your scraping algorithm when it would take about the same amount of time to loop over every page and pull that big data set. You think, let me just pull it all. That way I have the data if I want to use it in the future, but let me pull out this specific piece of data to use going forward. So what I'll do is define an empty dictionary. This one's going to be cluster dict. Using the cluster data frame here, I'm going to use the dictionary update function, and I'm going to use pd.series, okay, and I want the cluster, okay, as values, and I want the index equals cluster df player, and I'm going to send that to a dictionary. So real quick, if we want to run this, let's see what we get. Unexpected and what am I missing? Parentheses. So this is what that's outputting, right? It's just a series. So what that means is when we have an index, A series is basically just like one column. So this is a data frame because our index is numbered, just enumerated, just 0 through to the end. And then we have 2 data values for that index. There's only one data value for the index, and that's a series, which is basically just a single list of data. So we pull that, and then we can use the toDict function to basically just convert this to a dictionary. So if we go ahead and do this, new dict equals. So just to break this out step by step so you can see what's happening, because that's doing several different things at once. So if we go ahead and run that, then we can take a look at new dict, and we can see we have a dictionary of player names and their cluster. Okay, Anthony Simon 0, Bobby Portis 9, so on and so on. So what we're doing here is the dictionary update function. You have to pass a dictionary to it, keys and values, and it will update those keys and values into your dictionary. If that key is already there, we'll update it with the new value. If that key is not there, we'll add the key and add the value for it. So that's just kind of a quick, easy way to populate an empty dictionary, all in one step. We could have done it, step by step like I just showed you, but we're wanting to do things efficiently, so we have 1 line of code instead of 3, 4, 5 lines of code. So we can go ahead and run that, and now we take a look at cluster dict now. Now that we've updated, we have the exact same thing as we had up here for new dict, right? Langston Galloway 12, Anthony Simon 0, Langston Galloway 12, Anthony Simon 0. Now, as far as getting this into our data set, Pandas has a replace function, and I think we've gone over it in a previous video here. If not, I may have just mentioned it. But it's a pretty easy way, especially if you're working with dictionaries, which is what I like to do if I'm having like single data sets like this. First things first, we need to define a new column in our data set called cluster, so we can have some place to store the cluster. But notice I'm making it equal to the player column. So when we see this, we have the player here, and we have the player here. So the reason for that is the player name is the key in our cluster dictionary. So when we run the replace function over our pandas data frame, it's going to replace the key with that key's associated value, okay? So let's see, we did that. So now we take dataset cluster equals dataset cluster dot replace, and we're just going to pass the dictionary to it, and it knows what to do. It's going to go through that cluster column, and if that key is part of the dictionary, it's going to swap out the player name for the value in the cluster column. So let's go ahead and do that, and then we'll take a peek, and sure enough, we've got our clusters. Okay, doing good so far. But you may be thinking, what if every player doesn't have a cluster? Because I would recommend anytime that you want to be doing clustering, and I don't think I did it with this data set because we just wanted to keep it simple and kind of go over how to do it, not necessarily what's the best strategy to implement it, is you kind of want to pare down your player pool coming into it. For instance, you may only want to incorporate players into your algorithms that play an average of 10 minutes a game. Because if they're playing less than 10 minutes, they're probably not scoring very many fantasy points. And there can be one-offs. If a player's injured and a backup is playing, then obviously you want to account for them. So you can kind of manually tweak some things for them. But for your daily stuff that runs every day, you don't want to have to worry about it. Maybe players that have played 20 games or more. You don't want those players that, played 1 or 2 games and then have been injured, haven't played a lot. Or maybe they just came up from the G League and they don't have very many games under their belt, but they played really good in their first game because they were injury riddled and they got a whole lot of playing time. Things like that. You'll kind of want to take into consideration because you also want to make sure you have a good sample size for that data. Look at a player like Taco Fall with the Celtics. He doesn't play in a lot of games and he doesn't get a lot of minutes, but his per minute numbers are absurd, right? Because he does a lot, and that garbage time he gets in, he gets blocks, he gets rebounds, he gets points. He only played 40 seconds. He got 2 blocks, 3 rebounds, and 6 points. Like, if you scale that number to a per 36, it's going to look like he's the greatest player of all time, right? So you want to factor those things in when you're pulling your data and be aware of it, especially depending on what data you're bringing in. If you're just bringing season averages, that's fine. If you're doing per 36 or per 100 possessions or whatever, then you start to really need to worry about that kind of stuff because they can get out of control fast. So one way to quick check that and see if everything came through is just do a quick info command on your data set and look at cluster. We can see the data type is an int64. That means that every single value in that column is an integer, which means they were all swapped out. Otherwise, it would be an object because it would be a combination of strings and integers. And if that's the case, it's going to pull object. So, and it's good to check this anyways to make sure everything's coming through fine. The more data sets you have that you're compiling and bringing together, the more important it is to keep track of this because the more likely that something's going to slip through that isn't done right. So you can build different things into account for that. You can say, you know, if it didn't sub them out, just plug in their season average or their last 3 average or whatever you want to do. A lot of times for the cluster, like if they don't have a cluster average versus that team, or if they don't have a player average versus that team, I might just sub in the cluster average against that team as a placeholder, or I might sub in their season average as a placeholder. You can do all sorts of different things. The important thing is that the exact same data columns are being fed into your model every time you run it. So it's not a huge deal if you have to swap something in here or there, but you have to pass a value for it. So now that we have our clusters, so what we're going to do here is just kind of define a data set for each cluster, okay? Because we're going to step through this a little bit one at a time. So you don't need all of these manually. You can just do like a couple of them and walk through. So let's look at cluster 0. So for cluster 0, we have 2,382 game instances that a cluster 0 player played in. So if we take cluster 0 and we want our DF features to be the last 3, 5, and 7 again, because that's what we're working with, but just for the cluster 0 players, and we want to take a look at, well, here, let's first do fantasy points. And then we'll do average difference, and we'll see how different it is. So then we can do, and again, this is going to be very similar to last video, so we're not going to, you know, take the time to go through each of these steps. We're just going to run through them and get some results. Okay. So df0 describe. So going for fantasy points, we can see our average error is 8 points on cluster 0 players, and we didn't review cluster 0 players, so we have no idea if that's a good cluster or a bad cluster. And keep in mind, this is also just raw fantasy points. And we built our clusters off of play styles. So you could potentially have a pretty wide range of minutes being played per game for each of the players in these clusters. You might have, you know, it may skew towards similar, like, you know, starters are going to be in the same clusters, but not always. Sometimes you get some bench players that get bumped in there because they have very similar play styles. They may not be as effective, and they may not get the minutes, but they have a similar play style to some bigger name players. And that can give you a little bit of trouble. So I think fantasy points per minute is probably a better thing to be looking at when you're doing these types of clusters. But to keep it simple, we're going to be using fantasy points. So our average error, yep, was the 8.15. Now if we go through and do the same thing, but average difference, and we'll just do df1 for each of these so we can compare the two. So now this, remember, is us predicting how far off of their average season production they are for this game. So let's do df1 dot describe here. Whew. Our average error was a lot higher there, so this is not a better way to do it for this data set. So it can be a little bit better, a little bit worse. Again, with fantasy points per minute would probably be a more accurate way to go about this because it's going to be a smaller range. So you're going to get more accurate results, and it's going to come down more to your minutes and whether you can correctly predict that or not. But all that's up to you and however you want to build your model. I'm just here to show you kind of how to do different things. So going forward, let's go ahead and use normal fantasy points because that was much more accurate with this. I'm going to go out on a limb and say it would be more accurate for some other clusters. It's not what I did for prep, but we're going to roll with it and see what kind of results we get. So if we want to create a model for each cluster and we want to compare those results, maybe see that we're very inaccurate with one cluster but very accurate with another, and we want to kind of take that into consideration when we're weighting how much we value the results that are coming out of this. So what we can do is, first off, we need to think about how we want to do it. So writing some pseudocode here, what do we want to do first? So we need to identify unique list of clusters to loop over. And that's going to be a for loop. To for loop over. Okay. Once we have that, we need to loop over clusters, and we need to print out results. So if we think about that, we want to, for each cluster in this list, we want to, and then we're still in our for loop here, we want to create dataset for cluster, create, train, and test datasets for cluster, train and test model, review results, repeat each cluster. Okay, so that's kind of how we need to build this out. And by the way, if you're trying to create something, kind of writing it out in English in the same format that you'd be writing the code is really helpful, because then you can come in here and you can say for cluster in list, okay, and then we want to come right down here, cluster df equals cluster da da da, etc., etc. So you can keep those in your code if it helps you. You don't have to do it all separately. I just want to do that to kind of walk you guys through what we're about to do, because I don't think we've done anything quite like this before. So the first thing we need to do, identify unique list of clusters. So first thing I'm going to do is take, remember we have cluster df, which is our player and cluster. So I'm going to take that cluster column and just convert it to a list and call it cluster list. Simple enough. So now I have a Python list of just this cluster column with each item as its own entity in the list. That's great, but I need a unique list, okay? Because I want to loop over each cluster one time. Now, there are some easy ways to do it. Easy thinking wise, what makes sense, and easy code wise is to keep it clean. So doing things how we've done them so far, we could define an empty list called new cluster list, and we could say for cluster in cluster list if cluster in new cluster list. Actually, we'll just do if not cluster in. So what's that saying? We're looking at our big cluster list here, right? And we're looking at each cluster. If that cluster is not in our new cluster list, new cluster list dot append cluster. And we're actually going to, yeah, we'll do that. Okay. So now let's look at new cluster list. 12, 0, 9, 6, 3, 4, 7, 2, 11, 5, 1, 10, 8. Cool. So that worked, but that's a whole lot of code. There is a data type in Python called a set. A set is going to be very similar to a list, except there are going to be no repeated values. So we can have new cluster list equals set. Okay, we'll do new cluster set equals set cluster list. Okay. Now let's take a look at new cluster set, and we can see we have curly brackets like a dictionary, except It's not a dictionary, it's a list. Well, it's a set, but it looks like a list. We don't have keys and values, we just have items in our data there. So now what we can do is convert that to a list. So new cluster list equals list new cluster set. We run that and we check, and now we have our new cluster list. Perfect. So what I'm going to do is that same thing, except we can do that in one line of code. Unique cluster equals list set cluster list, because we have cluster list, right? And what that's doing is we are turning to a list the set of cluster list. So we're going to run that, and now I have our unique clusters. Okay, so we don't need to run this anymore. Now we're going to get to this in a minute. It was just an issue I ran into while I was testing, and we're going to see if we run into it again. We'll come back to it if we need to. So let's think about what we need to run again. For each cluster, we want to create a data set for that cluster, create train and test data sets for the cluster, train and test our model, review our results, repeat each cluster. So let's see what we have here. For cluster and unique cluster list. Oh my goodness. All right, just so I don't have to rewrite all of this. Unique cluster. Okay, unique cluster list now equals unique cluster, which is what we had here. So let's go ahead and double check that just for peace of mind. And yeah, we have that list again. Cool. So for cluster and unique cluster lists. So that means for every single individual cluster, we're going to do all of this before we move on to the next one. So cluster data, data set cluster equals cluster. Okay, so far so good. We are going to we're going to slice our data set to only look at these clusters. DF features, cluster data, last 3, 5, 7. Cool. DF labels, cluster data, average difference. Remember, we're going to do fantasy points this time though, because we like those results a little better. And the important part here is we're looking at this process right here, looping through each cluster. Create our labels, create our features, DF labels, DF features. We're going to do our train test split, features, labels, test size 0.4, random state 10. And random state 10 is what we used up here as well. So we're doing the exact same parameters that we just used up here. Then we are going to use our decision tree regressor. We're going to fit it. We're going to predict. We're going to take our predictions, and we are going to create a data frame where we look at our last 3, 5, 7, and we pull in our test data frame, or rather our test data set, sorry. Pull in our test data set after we've trained it, and we only want the last 3, 5, 7 from our test data set. Then we're going to have our df0 actual be test labels, df0 predicted equals predictions, df0 error. We're going to take the absolute value of our actual minus our predicted, because we want to know raw how far off we were. And then we're going to print out what the average error is for each cluster. We're going to print cluster, and this we're using an F string here, so we're going to have a variable inside these curly brackets, and that's going to then print that variable out in the string. So we're printing out the cluster number, which again we're pulling from our unique cluster list, and then we're going to look the average error is df0 error, and we're just going to run to get the mean on the error column. Okay, so we run that and we take a look here, and we're getting an error. It says within samples equals 0, the resulting train set will be empty. Adjust any of the aforementioned parameters. Okay, so let's take a look. So let's look at our clusters. We ran through on 7 and we errored out on 8. So let's look at our cluster 8. Only has one player, so we can't break that into a train and test data set. No problem. I could care less about Paul Watson. So we're going to come up here and we are going to use the del command to delete unique cluster list, the 8th item in it, because since we start at 0, we know 8 is going to be the 8th indexed item because Python starts at 0. Okay. And we look at that, and sure enough, we jump from 7 to 9. So we're just going to run this again. And sure enough, we go from 7 to 9, but now we get the same problem with 10. So let's open up Excel and take a look at cluster 10. And okay, 1, 2, 3, 4, 5, 6. We have multiple in 6 now, but it's still giving us a problem. N samples equals 0. So we'll do a quick check. And we're just going to run this up here. And we're just going to take a look at 10. Okay. So nothing comes through there. That must mean we have them in our cluster data set, but not our box score data set. So let's take a look at some of those players and see what we got. Do a little bit of troubleshooting here. So let's see if we can find Mr. Jordan Bone. Nope. What about Mr. Jonah Bolden? Nope. KZ Akbala. Nope. Yeah. So we don't need to go through all of them. We've identified what the problem is, and that's what I'm talking about. You want to make sure to have some sort of standardized data pull as far as your filtration goes. So if you only look at players that have played X number of games and averaged X number of minutes per game, you want to make sure to keep that static across every time you pull data. And that's easy to do with the NBA website, scraping from them, because that's something you can put right into the URL. Okay, not terribly difficult. But obviously these two data sets were pulled with different requirements, which is not a big deal. It's good to kind of show these things. So we're going to go ahead, and now we need to delete this column or this one out because we've already deleted 8. So delete 10, and now we'll have that did not work. Oh, that also did not work. That is because I am all out of sorts here. So do them both, and we're doing it to unique cluster because unique cluster list is not defined. So 0, 1, 2, 3, 4, 5, 6, 7, 9, 11, 12. Let's run her again now. And 0, 1, 2, 3, 4, 6, 7, 9, 11, 12. So now we can look at the average error for each cluster. We can see clusters 4 and 5 were the worst. That's interesting. Let's take a look at clusters 4 and 5 and see if we can just real quick figure that out. All right. That's a pretty interesting grouping of players there. And that makes sense because you're going to have, you know, the Joker, Simmons, Devin Booker, LeBron, Mitchell Robinson, Tatum, Antetokounmpo, Ingram, Middleton, AD. Come down here, Bismack Biyombo, DeAndre Jordan, Tony Bradley, Kem Birch, Chris Silva. How many minutes does he play a game? What do his fantasy points look like? I guess that's 4. I'm sorry. I made a mistake. Let's look one at a time. So for 4, you got big time names scoring lots of points. And that's actually not too bad. They're going to score points in very different ways, right? So that's something we'll want to take a look at as to how our clusters were defined and what stats we used, because we obviously kind of want, like Russell Westbrook and Karl Anthony Towns should probably not be in the same cluster. LeBron James, Devin Booker, DeMar DeRozan, Julius Randle, Ben Simmons, Nikola Jokic. How many different play styles are involved there? Like, these are team stars for sure. They're number one options on their respective teams for the most part, but they're going to score very differently. And that's something that's good to take away from this. Looking at 5, looks like we've got some big men here, but there's going to be wild variations in how many points you can expect them to score a night, right? So let's try something else real quick that I think will be fun to try and something that I have not done before. So we're going to do our clusters again. So we're going to look at our cluster, but we only want sorry. What was it? Season av? Only if they average more than 15 fantasy points per game. Okay? So all those guys that average absolutely nothing, that are probably really messing with this, because then let's be honest, if you average less than 15 points a game, do I want you on my roster? Like, I only have so many slots. Probably not. So let's throw that in. See what we get. Invalid syntax. That is because I did not close that parenthesis. Yikes. Cannot perform ran with D-type and scalar of type bool. What did I do wrong? Okay, you know what? We're not going to mess with that. We are going to we're going to make it easy on ourselves. We're going to do dataset 2 equals dataset such that dataset season av greater than 15. Dot describe season av min 15. Okay, that worked. Perfection. So now we're just going to drop that in, and we're going to pull from dataset 2 instead. Easy solve. Let's run that. Invalid syntax equals cluster. We don't need that. Okay. 4 and 5 is still 10. That makes me feel like I messed something up. But I didn't. Okay, so that's something to consider as far as who's in each cluster and how they're broken out, and whether or not we want it to be the same or we want it to be different. That's the bulk of what we're going with today. We don't want to get much farther because we want to kind of break this out into pieces. Next time we'll look at how to save a model. When you get one that you really like, you want to keep using. You don't want to have to go through this process every time. You just want to call your model, point at your new data set or your most up-to-date data set, and then get your predictions or your clusters, whatever it is that you're looking to do. And that's going to be that. So thank you guys for watching. Thank you to everyone on the Patreon. And I will see you guys on Saturday with some more lineup optimization information. Thanks.